All right. Welcome. I'm Mr. Woodbury. Today's video is on diffusion and osmosis in cells. Before we get started, our learning objectives for this video. That's what you're going to get out of this video, hopefully. A solution is the combination of a solute and a solvent. There's an inverse relationship between the solute concentration and the solvent concentration in a solution. The terms hypotonic, hypertonic, and isotonic are used to compare the concentrations of the solutes, and thus the solvent, in a solution to those inside of a cell or object. Diffusion is the movement of molecules from an area of high concentration to an area of low concentration. And osmosis is going to be the diffusion of water molecules through a selectively permeable membrane. All right, let's jump right in. I'm going to move my camera here. That'll be better. Okay. Solutions. So solutions are made up of the combination of a solute and a solvent. For example, sugar, water. Okay, so here we have an example of sugar water. In this case, the solute would be the substance that can be dissolved in the solvent. So that would be sugar in this case. And our solvent would be whatever is doing the dissolving, okay? The substance that dissolves the solute. In this case, that would be the water. Okay, so in this case, we've got our solute right here. And we've got our solute right here. We've got our solvent right here. You put them together and you have a solution. Cool. Wow. Might just have to remove my camera. We do have an inverse relationship between solutes and solvents in solutions. That means an opposite relationship. When one of them is high, the other is low. Okay, so maybe I'll use blue here. So we've got a whole bunch of these water molecules, right, in these beakers. And there should be about the same number of water molecules in both of these beakers. Okay, but as you can see, the concentrations are not the same. In this one over here, we have sodium ions. Okay, we have several of them. Okay, several of these sodium ions. Okay, we have several of these sodium ions. And we have one over here as well. Okay, but clearly the beaker on the right has more sodium ions. Okay, and what do you notice is happening around those sodium ions? Okay, those sodium ions that are dissolved in the water, they are actually reacting with the water to an extent. So the water molecules kind of clump around them in this way. It has to do with polarity. Okay, it has to do with the charges of the water molecules and the sodium. But what's happening here is that these water molecules are kind of holding on to this sodium molecule in solution. Okay, that means that there are very few free water molecules on this right-hand side. Okay, there's only these free water molecules. Okay, over here, as you can see, I won't circle all of them, but there are a lot of them over here. So this side over here, the left beaker, has a lot of free water molecules. Okay, so the water molecules on this side are high. The sodium molecules on this side are low. Okay, over here on the right-hand side, the water molecules, the free water molecules, are low in concentration, and our sodium molecules are high in concentration. So we have this opposite relationship. Whenever you have a high solvent concentration, you have a low solute concentration. Whenever you have a low solvent concentration, you have a high solute concentration. To kind of explain this a little bit more, we've got some practice on the next slide. Okay, so let's see if I got my pen here again. We'll do orange. Okay, when solvent concentrations are high, okay, so think about this. When solvent concentrations are high, our solute concentrations are, okay, maybe pause the video for a second, think about what your answer would be, and then resume. Okay, if solvent concentrations are high, then solute concentrations are going to be low. Okay, when solvent concentrations are low, solute concentrations are going to be high. Okay, so we have these two practice problems here. Go ahead and pause the video. Think about those ones right there for a moment. Okay, maybe write it out on a piece of paper. Which ones would be high and low? Pause the video and resume when you're ready to review your answers. All right. So in this case, you add 2 tablespoons of sugar to a glass of water. Okay, so your solute concentration is going to go up. Okay, remember, sugar is going to be a solute because it's dissolved in our solvent, which is water. Okay, so if our solute concentration is higher, that means that our water or our solvent concentration is going to be lower than it was before. And over here, if we boil off some of the water, okay, leaving all the sugar molecules in solution. So now there's still the same number of sugar molecules, okay, but our solvent concentration is going to go down, okay, because we've got less water now. So how is that going to affect our solute? Okay, a smaller concentration of solvent means a higher concentration of solute, okay. And then lastly, we add some fresh water to our sugar water solution. Okay, so as the solvent concentration goes up, as we add fresh water, we would expect our solute concentration to go down. Okay, wonderful. So next up, we've got hypertonic, hypotonic, and isotonic. Okay, area of a lot of confusion. Hopefully, this will make it a little better. So solutions can be classified as hypertonic, hypotonic, or isotonic based on how they compare to cells or objects within them. So if you're just looking at a solution and it doesn't have any cells or objects in it, you wouldn't necessarily call it hypertonic, hypotonic, or isotonic unless you're comparing it to something. Okay, so in this case, we've got a cell drawn in the middle here. Okay, dramatically not to scale, right? This is a gigantic cell in a beaker. Okay, but if we're comparing the solution outside of the cell, so if we're comparing the solution to the cell, okay, then we would use terms like hypertonic, hypotonic, or isotonic. Okay, so we're thinking about the cell. We talk about whether the solution is hypertonic, hypotonic, or isotonic based on how it compares to the concentrations inside the cell. Okay, what we mean by that. Okay, so hypertonic means that there's a higher concentration of solutes in the solution than there is in the cell or object. Okay, so if we've got, I'll just draw these in. Okay, so if we've got, I'm going to make just these little X's out here in solution. Okay, let's say that these are little molecules. Okay, these are solutes in solution. Maybe this is the sugar from our sugar water, or it could be salt, or any number of things. Okay, so we only call it a hypertonic solution if there is a higher concentration of those solutes outside. Okay, so in this case, we would have to have a lower concentration of those solutes inside. So see how there's a little bit less space between molecules outside solution and more space between them inside. That means our concentration of these molecules is high outside and it's low inside, meaning this is clearly going to be a hypertonic solution. Okay? However, a hypotonic solution is going to have a lower concentration of solutes in the solution than in the cell or object. Okay, so I'm going to put the same number of solutes into our cell, okay, because the cell doesn't really change much. Okay, But it's really a comparison of the water outside of it, the solution outside of it. Okay, so in this case, there's going to be a lower concentration of solutes in the solution, which would look maybe something like that. Okay, see how there's very few of them? They're very spread out. The ones inside, technically, these are closer together, right? They occupy more of the space inside the cell than the solutions out, the solutes outside. Okay, so this would be a hypotonic solution because the concentration of our molecules is lower outside. And then lastly, we've got our isotonic solution. This is going to be when there's an equal concentration of solutes inside and outside. Okay, and this one's a little bit tougher to draw. Okay, but I'll see if I can get it pretty good. What you should really look for in an isotonic solution is that the spacing between all the molecules inside and outside the solution are approximately equal. Okay, so in this case, I think I did a pretty good job here. The spacing between our molecules here is pretty equal. Even though there's more of the molecules outside technically, there's also more space outside. So because the distance between our molecules outside is about equal to the distance between our molecules inside, we have an equal concentration, which means we've got an isotonic solution. Okay, so hopefully that was helpful at figuring out whether a solution is going to be hypertonic, hypotonic, or isotonic.